We had expected to have Shane share the stage with Jill Marlowe, but unfortunately her grandchild gave her the flu, so she's out, and we thank her for not, sharing that with the rest of us. All right, so Mr. Shane Dover, he's currently assigned as Director of the Aircraft Capability Management Office at NASA headquarters. In this role, he's responsible for the centralized management and strategic planning of NASA aircraft capability, capacity, and the efficient use of NASA aviation-related resources. What he says is he talks more about aircraft now instead of executing the mission hands-on, which he misses already, and he's not even been gone there that long. And now you'll understand why. He is a man of action. Prior to the assignment at headquarters, Mr. Dover served as our Langley Director of the Research Services Directorate and the Chief of Flight Operations, where he was the senior line authority of not only our research flight activities, but the UAS new activities and the research flight simulator operations. That is a breadth of capability. Wow. I mean, it's impressive for a research center to have that. So I can't wait to hear what you're doing with everybody else. Previously, Mr. Dover held numerous positions within NASA, Chief of Flight Operations at Goddard, Aviation Safety Officer, Airworthiness and Maintenance Manager, Test Director, and NASA Research Pilot. His awards within NASA include multiple honor awards, the nation's agency honor award for outstanding leadership, and the Interagency Committee for Aviation Policy Federal Aviation Professional Manager Award. Woo! All right. He is a native of South Portland and graduated from Rensselaer Polytechnic Institute with a Bachelor of Science in Mechanical Engineering. He was commissioned as officer in the United States Navy through the ROTC program and achieved the rank of captain. His naval career encompassed more than 25 years. We now welcome Mr. Shane Dover. All right, and Shane promised to talk to us about what he did at Langley, what he's doing at headquarters, how difficult the change in culture and changes in process are in such a broad agency. And let's see the progress that you've made in what amount of time. Okay.
Excellent. Thank you, Vicki. And I appreciate the invite. Thank you. It's an honor to be here, especially with such aerospace stalwarts as yourselves. So thank you for inviting me. That bio is, it sounds like it's a broad perspective, but really I spent the majority of my life in aviation. So my expertise is almost entirely in the aerospace world associated with aircraft and UAS. So that's almost entirely what I've done. That said, I was supposed to be sharing the stage here. I keep looking to see if maybe Vicki's, I'm sorry, if Jill's on, maybe. I was supposed to be sharing the stage today with Jill, and my plan was to completely follow Jill's lead as I did the whole time she was here. I find her to be much more intelligent and articulate than myself, so I try to just get behind her, and then when she asked me questions, I answer them. That's how I played for a long time. So I wish Joe could have been here today because it would have been a much better talk. How's that? I do want it to be interactive. So if you have questions and stuff, please feel free to ask along the way. And I'm happy to talk about them. I'm also happy to see some familiar faces in the crowd. Thank you for showing up and the support. I appreciate that. But it does limit the things I can talk about because now I can't lie about you, Tommy. You know what I'm saying? I can't tell I can't tell the lies because he'll call me up. Yeah. So as mentioned before, primarily, my background is in operations. So I was a Navy pilot. After being a Navy pilot, I went kind of into the research world in the Navy and into NRL, Naval Research Laboratory, where I did work with UAS and some other things, but mostly operations from a Navy perspective. Then had a very brief stint in the airlines where I flew for an airline that doesn't even exist anymore, Continental Airlines. Technically, Continental bought United, just so that everybody knows, that a small was good on the stock market, I guess, but in the big picture, they kept the United symbol and painted the aircraft with United on it. So that's how that goes. I flew for them for just a few years and then got picked up by NASA, where I worked for Goddard Space Flight Center first. So in that realm, all I really did, I didn't get a chance to go to any graduate level education, because my graduate level education was flight school, 3 years with the Navy, and then went right into operations. So really, I feel like when I hear some of the credentials that were mentioned earlier, I'm not that well educated. I feel rather uneducated, but I'll do my best to talk about the topics at hand. So all that said, at Langley, I was asked to kind of talk about the things I did at Langley. So I was the director of the Research Services Directorate, and as Vicki mentioned, that encompassed kind of a wide variety of things. So in 3 major areas, the first one was research aircraft operations, where we serve 2 major, well, 2.5 maybe, mission directorates. The first one is the Science Mission Directorate, where we flew research on behalf of science. The second one is Aeronautics Research Mission Directorate. Largely the things we did for ARMD had to do with what we call risk reduction flight test exercises. And a perfect example of that, and one that I was proud of just before I got kicked out of that job and put into stuck up at headquarters. But an example of that is the XVS system. That's the external vision system for the boom flight demonstrator. And this is just a great example of how the agency comes together when they have a common goal and they're working towards something. So it turns out that if you want to have a low boom on an aircraft, so the laws of physics preclude you from having a forward-facing view. You can't have a canopy, you can't have a window, it has to be perfectly aerodynamically shaped such that it minimizes the boom. And in order to do that, the pilots need to be able to see. So we developed a system here at Langley. It's an interesting, awesome system. I did not develop it, but the external vision system was developed within, it was actually between RD, ED, and RSD. That system was developed with our simulator folks of all folks. Because the technologies are similar. So you're displaying something on a display. So the pilots will look at a display that has several cameras looking outside that are real time, but then also additional information overlaid on that display. So by the time they got done with this technology, as an old time aviator looking at the screen, I can tell you that it was a better picture than if you were looking at it yourself. It could see airplanes farther away. It could identify runways quicker. It was an awesome system. So our role on that at Langley was we were going to flight test that particular piece such that when low boom actually flies, we knew that piece had already been flight tested and was proven. So that's kind of the role that we've played, this risk reduction flight test exercise for these smaller components that will wind up in these bigger projects. Awesome system, just one example. So the next area was the uninhabited aerial systems, and I'm looking at Tommy because that's his branch. Very early on, I was speaking with Vicki earlier, and I'll digress for just a second. Langley benefits from people with vision. And I think in this agency, and I'll complain about it a little bit later, we lack vision sometimes because we get so used to doing the same things that we did yesterday. But there are a few people that look out over the horizon and see these convergences of technology and see these things that are going to take us into the future. And it's those people that not only do they have to be existent in your organization, but then they've got to be vocal and then they have to be heard. So we had the benefit at Langley, even when I first showed up here, 2015, we had Vicki was one and Jill was another, the two that I thought kind of echoed that idea of, hey, vision is important. So where do we need to look in the future? And one of the areas that both those ladies looked at and saw and demanded, literally, I remember Vicki raising her voice in a couple of meetings and maybe even calling some names of some people, but they recognized that uninhabited aerial systems, UAS or drones as they're called now, I hate the term because drone is actually something you never intend to get back. We already had that name was used, and then we repurposed the name. So a drone now is a UAS, I guess. But they saw a future that UAS operations were ubiquitous with day-to-day operations of all things. And they saw this vision that a lot of people did not see, especially aviators, because we have a tendency to look down upon things that don't have a pilot in there manipulating controls. So who could trust a machine to fly itself? And who could trust that machine to fly amongst things that had people in them? But there were a few people, and Vicki and Jill were two in particular, that said, hey, actually, this is the future. this is where we're headed. It's plain to see if you look far enough ahead that this is where we're headed. So with that vision, vision alone isn't enough. They also had the determination to ask for resources, to push for projects that would further that evolution. And with under their vision, decision, and communication, we ended up landing an incubator program here and then developing a test center called Certain, which is a test range. Tommy, I'm going to try it. So back, I'm going to try to tell you what Certain stands for, but I may get this wrong. So here it goes. The city environment for the testing of autonomously integrated navigation. Okay, go. Range testing. Okay, city environment for the range testing of autonomously integrated navigation. I do not take credit for the acronym because it's horrible. It's a horrible acronym, Tom. I hate it. Actually, it's the worst acronym I think I've heard since I've been at NASA, but that's okay. The idea was awesome. And what that idea was, and Vicki and Jill get the credit for this vision, was, hey, if we're going to eventually live in a world where these things are going to zoom all around us and be part of our airspace and our day-to-day activities, everything from first responders, rescue missions, policing, perhaps, into traffic. Instead of flying a helicopter to look at traffic, you can have this thing go look at it. But there's a lot of activities that you could do, but you're going to have to test that in an environment that mimics the environment that it will eventually, the representational environment is kind of the TRL 6 definition, a representational environment. And that environment is an urban type setting. That is buildings and trees and people walking around and disrupted airflow around buildings and the electromagnetic spectrum being interfered with and blocked and GPS being blocked, and all those things represent the realities of what these things will be expected to do. So where better to do that than at a NASA facility where we can control and therefore have a control over the risk of those things. So they saw this need, and they saw a vision in where the country was headed, and then they put in place a range that allowed us to test those things. So a couple of the big assets that I was able to further once I sat in the seat of RSD was based upon the vision of both Vicki and Jill, who said, hey, these things are going to be a part of our future, and we need to have some means of testing them and developing them. So the Certain test range is one thing that Tommy's group manages. It's an awesome asset for the agency and has already developed technologies that are being incorporated in various aspects around the country. So UAS was one world, and then the last world that I was responsible for was research simulation. So out of you would think that an unpiloted vehicle was the thing that bothered me most, but actually coming to work here and then working in the research simulation world was the thing that probably threw me for a loop the most. And the reason was because the pilot in this case was not a member of the test team so much as the guinea pig. So we would take pilots, and the ideal pilot was not a NASA test pilot. The ideal pilot was a pilot who flew it for an airline on a day job, and to pull that person off the line and put them in a simulator, wire them up with electrodes to see what they were thinking about, and then have scanners that can scan their eyes. Our research simulators right down here can do all that in a cockpit that exactly mirrors those cockpits that they fly in the airlines. And then we can test various means of human-machine interface. So if you know anything about pilots, you know that pilots like a good story, and the last thing they want to tell you is the truth a lot of times. So when you put a pilot in a very demanding circumstance, that pilot, and I've been there before, and shoot this approach down the minimums and break out late and make this last minute dive for the runway and land it perfectly. And if you ask the pilot, how was that approach? They'll say, oh, nothing to it. But the difference is in the simulator, we could tell you, it was funny because your brain appeared to be completely saturated. Your eyes were going all over the place. You weren't looking at the right things. So it was that true test of the human performance in the simulator, that truth data that really kind of drives the research simulation. But it was in the research simulation that I realized that human-machine interface, that human-machine teaming was the next step before we got the fully autonomous things. So as a naval aviator, I'll tell you, the Navy paid millions of dollars to train me how to fly airplanes. As to whether or not they did a good job, you can ask people who have seen my landings, perhaps not so good job. But I would say the Navy very much put its money where its mouth is when it came to its aviators. When weather got worse, when conditions were horrible, when you had to make those split-second decisions, the Navy actually said, hey, turn off the automation. I want you to turn the autopilot off. I want you to fly the approach by hand because you're the best instrument to do all those things. And I kind of grew up believing that. Hey, man, things get bad. Turn off all the automation and fly it by hand. It was in the airlines that my eyes were opened to the machine that could do it better than I could. So it took a few approaches. Now, in training in the airlines, they teach you a lot of things, but one of the things they teach you is how to do is what's called a 0-0 approach or a zero visibility approach. And essentially the airplane flies itself down to touchdown. And I can tell you as a naval aviator, there was nothing more scary to me than the idea that I was going to let this machine land. And I was not a big fan at first, I will be honest, as I think a lot of people don't embrace that technology. But then a couple mornings in Houston, flying into Bush Intercontinental Airport, when I saw that machine, I couldn't see the runway at all until we touched it. And that machine put it right down on center line, right in the touchdown zone on speed where we should have been. And I became a believer. I did that enough times, duplicated that enough times that I said, wow, this thing can actually do better than I can. So with that said, I became a believer through the airlines that autonomy can be something that aids the human in performance and makes us better, just makes us perform at a higher level that we could not perform by ourselves. So it was in the research simulators here that I came to understand that this human machine teaming was the next phase. How best to incorporate the machine to aid the human to be the best combination, that best team together, and make those decisions and provide to that pilot the information they need to know, not the distracting information. I grew up flying round dial airplanes that had, we call them steam gauges, but kind of analog gauges. And then when I left the airlines, we were flying all digital things. And the problem with that is you can get a lot of information. That's awesome. But it's also an issue because there's times when I don't need to know the 500 things I'm being displayed. I need to know 3 things that are going to keep me alive. So have a machine that understands when I need the 500 things and when I need the 3 things. Have a machine that can tell me when I'm making a mistake, or even at times intervene when the pilot's making a mistake. I'm very touchy about that because I appreciate how about this? I appreciate the machine making a suggestion that I'm making a mistake, but at the end of the day, I still want the last vote. I want the veto and say, nah, that's not what we're doing. So those type of technologies have saved lives today. Everything from stick pushers and rudder shakers and the displays when you go into an unusual attitude. Our researchers right here developed technology that said, hey, you know what I'm going to do? I'm going to take all the displays across the cockpit because you obviously don't know where the ground is and where the ground starts or ends and the sky begins. So I'm going to show that to you right now. And I'm going to take all this other stuff away from you and say, this is the ground, one big attitude indicator. This is the ground, this is the sky. And you'd be amazed at how much situational awareness that gave the pilots to just get back to, hey, this one thing is all I need to know. Anyway, just another example of how this human machine teaming drove us toward these technologies that we've developed right here at Langley through those research simulators, and was a next step to what I consider to be the obvious future, which has to do with we will have human machine teaming in some vehicles, and we will have autonomous systems and others that do it completely autonomously. And it will depend on the application and the need. So those are the 3 major areas: research, aircraft operations. Then we had the UAS operations, including the certain test facility, which I consider to be bar none the best we have in the agency and maybe in the nation. There are others that simulate it or get close to it, but we have, I consider the breadth of research capability here to be bar none the best on the planet. And then we have research simulation that teaches how to interface with a human in a way that we can make best use of the teaming mechanism. So those are the 3 areas I was responsible for at Langley. I was here for 5 years, I guess, as the director of research services. I came on board with Vicki and Jill and others that were sitting as other directors. That was awesome to have the mentorship. Thank you to both to Vicki and Jill for those things. And then it was just eye-opening to see the vision they had and to see a center that was willing to pursue those visions when they saw that it was going to become something we had to do. So that's what I did at Langley as a kind of whole. I don't know if you want to break up into other sections or take questions about that and then move on to the headquarters thing.
Any questions here in the room?
About-
Do you want to start about what
about
we've
the
gotten so
past.
far? Yeah, the past.
Yes, sir.
Where is a certain facility at?
Well, you're sitting in one part of it. The short answer is, amazingly, it's the entire center now. So it did not start that way. So what the area that you will remember is the back 40, which is back towards the gantry area. It's a very wooded area back there. That was certain phase one, and that had to, we ramped it up in accordance with the risk overflight of human occupants, overflight of buildings and assets that had value. So we did certain through 4 phases. Thanks. I'm so glad you showed up, Tommy. I can pull a seat up. You can help. Yeah, so now certain encompasses the entire center, on top of the entire center, and directly abuts the Air Force's airspace. So it is, well, underneath the Air Force's controlled airspace, but directly abuts, essentially the runway becomes the demarcation between our side and theirs. And that's an amazing test facility, because they have everything from precise navigational performance, because you can't rely on GPS purposefully. So we do need truth data. So we have a completely independent navigation system that uses a commercial off-the-shelf product that allows us to have very precise navigation. And then there's other systems, I don't need to get into it, but just a remarkable test facility. Yes, sir. Does that answer your question?
Yes.
Thank you.
Any questions online?
We don't have anything in the chat, but there may be some individuals.
You got one back here.
Did I see a question in the back, sir?
Okay, all right, good.
Yes.
You got it.
What did you fly in the Navy?
The question is, what did I fly in the Navy? Well, I flew a bunch of aircraft, but largely a large wing guy, big wing guy. So P3 Orion is what I had the most flight time in the Navy. I've now surpassed 19 aircraft, I think. I've been qualified in 19 different aircraft. And I know that is no longer the aircraft that I have the most flight time, and I've flown many aircraft, many more hours than that. But airlines will do that to you, by the way. They burn through the hours in their aircraft. And in the airlines, I flew the 737, 757, 767, but the 757, 767 were one fleet, so we treated them as the same. So everything from a 767 down to a Cessna. At NASA, I had the opportunity to fly all kinds of, I got to fly the Hornet, the Eagle, the T-38, a couple different Gulfstream products, B-200 King Airs, T-34s. I mean, you name the airplane, I've had the opportunity. I've been fortunate beyond words, really, in terms of pilot. I've got to fly just about anything that's out there. So it's been fantastic. Thank you, sir. Appreciate the question. Any other questions? Okay. I think, oh, yes, sir.
Oh, thank you. I spent the early part of my career working in high reliability digital systems. So that was transitioning from analog to digital.
Yes.
And we hit a brick wall in the specification that the FAA told me of, I'll say it informally, 10 nines. Okay. And the fact of the matter is, you can't test to 10 nines. Okay. And so as I see this revolution, not only in autonomous cars, but, you know, aircraft especially, I'm wondering, you know, what is the basis for your optimism that you'll be able to meet this?
So the question is, why am I so optimistic? No, I'm just kidding. So validation is really what your question centers on, I think. So there are a couple pieces to that. So first of all, totally agree that validation of things, and I'm going to start kind of out of the atmosphere, not literally, but in terms of ideas, and then I'll throttle back to what we're discussing. If you embrace the idea of autonomous operations of any sort, you're not going to go far in that space till you get to something called AI, or artificial intelligence. And I have learned that that is not a great term, and that it means a lot of things to a lot of people. And if I say AI in the wrong crowd, I get yelled at for not understanding what I'm talking about. But really what I would talk about is non-deterministic machines. And I've argued with my brother over this topic many times, because he says, well, what does that mean? Everything's, you know, a machine just knows what you put in and what you put out. And that was the case for a long time, a bunch of if-then statements, right? And then you can go through logical operands and get to an outcome. And you can test that, to your point. You can test that. And I can say, hey, if I put in these parameters, this is the result I should get. And then did I get that result? How frequently did I get that result? That would tell me the reliability of a machine. But in the world of non-deterministic systems, well, before I tell you the problem with that, I should tell you the benefit. The benefit to a non-determinate system is you are one, which is to say, sometimes when a pilot saves the day in a mission and decides to do something, they come back and they said, hey, why did you do that? The pilot says, because I thought it was a good idea. And it turns out it was a good idea. Or, hey, I felt like this thing, notice the word feel is the operative word. I felt like if I did this, it would put me in a better position. Maybe it wasn't the immediate best thing, but I knew 2 steps from now it would put me in a better position. So non-deterministic systems allow us to get to advances where we can get machines that are more resilient to environments that aren't pre-described. So in other words, I come in for approach and there's something on the runway and or maybe I got to make a shift over real quick because I know something failed. So the machine can then make a non-deterministic a decision, which is very similar to what a human would make. We're far from incorporating them yet into aircraft, but I do think the day is coming. So non-deterministic systems are incredibly valuable when it comes to dealing with environments that are not very stable. However, the bad side is, how do you test a non-deterministic system? So if I put a bunch of inputs into a computer and at the end you say, hey, you say, what is the answer? And the answer is 7. And you ask the computer, well, why did you say 7? And it says, because I thought 7 was the best answer. You would believe that in a human, but you would not be okay with machines saying that. So ultimately, we're going to have to put our arms around how do you validate a non-deterministic system? How do you say that its result is, because it'll give you a spattering of results given over time. You put it through a Monte Carlo, it'll whip out a spectrum of results. And how do you determine whether a spectrum is valid or not? So there's the bigger issue. Getting down to validation now, I think where we've landed with the regulatory body, in this case, the FAA, is we just need to get enough data, which is to say we need to fly systems in controlled environments enough where they open the spectrum and allow us to say, hey, instead of 9, we can get to some other value that shows us that. So at the end of the day, it really is about validation of a system to validate that it's given you the result you want, how true it is. And I think the FAA was very nervous about it at first, but due to the fact that these technologies are now kind of ubiquitous and cars have actually led the way a little bit, it'll allow us to have some leeway with the FAA in terms of proof. So it's an interesting question. I don't think we have it solved yet, but we're working in that direction. What we're seeing with the FAA is a little bit, they're starting to say, hey, well, your answer is as good as any. And at the end of the day, I think that's what we need to get. But the bigger challenge is, how do we get AI incorporated in a way that we can trust it and know that it's given us the best result that we can come to? And that's a harder question. Yeah.
Yeah, I'm going to add a little bit about the AI business, if I can.
Yes, sir.
Use the common neural net type of architecture, because I worked with that during the same period, and I came away with the conclusion, because I was working in highly reliable systems and how you validate them. I said, yeah, the buzz phrase at the time was neural nets was the second best way to do almost anything. In other words, if you knew how to do it, then that's the way to do it. But if you train a network to do it, it'll do really well, but you don't know what it's going to do under all the circumstances. That's right. And this is playing out in with Tesla's.
I was going to say autonomous vehicles. We're seeing it today. Yes.
I mean, they have one of the world's biggest supercomputers training these neural nets, and you really don't know when it's going to run into something it hasn't encountered, and it makes a wrong decision. And this is what happens. This is what's playing out for us in real time.
The more complex the system, the more complex the environment, the more confounding factors there are. And those variables become this kind of infinite, not truly infinite, but close to infinite number of possibilities. And it becomes very difficult. Totally agree.
Yeah. Right. And it seems like you can blame a human being for making a mistake.
As they often do. Pilot error is the number one cause of accidents.
Yeah, controlled
Yeah,
flight
yeah,
into
yeah,
terrain,
totally.
right? So, but when it's a machine that makes the mistake, it seems to be a bigger deal. And
Yeah.
and this is another mental or psychological step we have to get over
Yes.
in this. Like,
What's
anyway.
interesting to your point, and can I just
Sure.
kind of walk down that path a little bit with you? A human makes an error in an aircraft and it hurts somebody, hurts something, takes a life. For some reason, we're more forgiving of that circumstance than we are if a machine made the same error in the same vehicle and caused the same loss of life. And it's just because at least maybe the human was on board and maybe there's empathy. Maybe it's, hey, we know that the human's life was at stake, so the human was trying their best to solve that problem. Interestingly, human error is all you could, and I've read entire papers on this, but you could claim anything as human error because ultimately a human designed it, and at least you could claim that anything's human error. But that said, truly, humans do error in aircraft, and they really have cost life. And when I've seen documentaries on how do we make things safer, but I'll tell you, one of the safest features of an inhabited aircraft is I want to go home too. Right. So I'm gonna do my best to get you where we're going, right? And to do that safely. And that is kind of this, it's hard to put a value on that. The fact that I'm there with you, right? And actually I'll be at the scene of the crash with you, right? So let's not do this. Let's do something else. So how do we step into a world, which I think we're going there, whether we like it or not, whether we agree with it or not, that's where we're headed. But how do we live in a world where that's the case? And can we accept a machine saying, well, I did my best. Mm-hmm. I did that because I thought it was the right thing to do. It ended in an accident. But yeah, it's a very interesting, and I think it's kind of a moral, ethical kind of question. It goes into the philosophy world. As an engineer, I'm troubled with the philosophy world. I don't do well with emotions, and I don't do well with philosophy. Yeah,
There you go.
they're non-deterministic. Yes, sir. Thank you.
Very much.
Okay, if there are any other questions on that, the great topic, and I appreciate the questions. I guess I'll step now into what I'm doing at headquarters. So, and I guess I've got to start with a problem, and I'm hoping, or I lived on the Eastern Shore for a while, and I learned a new word called hoaxing. I was hoaxing. I'm hoping that you guys can follow me on some of these because I'm going to bring up a couple challenges within the agency that I think are unique to NASA. And we struggle with them. And I'm just going to try to be honest with you all and hope that you don't kick me out of here and maybe someday invite me back or something. But here's what I think. I think the agency operated under a model for a number of years, and it was, hey, we had these 10 centers, and then we got into, I heard Jerry Creedon mentioned earlier, but 10 healthy centers, and we're trying to work toward, hey, what is it? How does each center play into? So the problem is we had no centralized enterprise horizontal management of those 10 centers for the most part. We had 10 centers that were each in of themselves a stovepipe that pursued what they considered to be their job, their role, their purpose. Given that circumstance under the right environment, that might be okay. And the environment I would say is if you had enough money to do all your missions and you had a little bit of excess thrust, in this case, extra dollars, it would allow you to make decisions that, you could, your bid and proposal or your incubator program, you can invest here and invest there, and you had more money to play with. The issue is what happens in an environment where resources are limited. Then all of a sudden you work into a realm where, hey, maybe this sub-optimized system with 10 centers making their own decisions on what they should be doing or how they should be doing it is not the right idea. Maybe that's not the best strategy. I'm going to fast forward and, well, in our case, I'll rewind a little bit, enter the world of Artemis, where all of a sudden, and by the way, I'm a huge fan. I think we should be doing those exploration missions, that we should be pushing the boundaries of what's possible. That's what NASA is supposed to be doing. So enter the world of Artemis. And all of a sudden, with relatively speaking, the same budget, they say, hey, we're going back to the moon and then we're going on to Mars. Well, we're going to need money to do those things. So now that puts us in a circumstance where we don't have those excess dollars to do those excess things. So in that model, you have centers that for years pursued what they perceived to be mission requirements, pursued what they perceived to be mission resources. So if they thought there was money in it or there was interest in it, they would go do it. And nobody was there to either check or validate or say, hey, man, maybe you shouldn't be doing that. Or, which we found, there's a center over here that's already doing that. Or there's one over here and one over here and one over here and one over here, and they're already doing that. And we don't need 6 of those. We need 1, maybe 2. So in that world, we found ourselves in a circumstance where we had sub-optimized by construct. And then when that fiscal issue came about, we landed in a place where we had to take a hard look at, hey, you're doing that because you're doing it too. And you've got 1 too, and you got 1 over there, and we can't afford 4 or 5. We can only afford 1 if we want to go to the moon and onto Mars. We have to make hard decisions. So here I was sitting happy flying, in a flying organization, doing the things I love to do, which is manage a flight organization, because I do field centers have a place in my heart because that's where the work is accomplished. And the advent of Artemis led to some fiscal constraints and some other things that led to us having to make some hard decisions. And the agency came up with an idea, which I do think is the right idea. It was, hey, we need to manage aircraft, both UAS and research aircraft across the agency horizontally. We need to look at this strategically. We need to look at it. Hey, if you got 1 over there and you got 1 over there, do you need 2? And there's a joke. I don't know if I say the word Brian Regan. Anyone know the comic Brian Regan? Am I the only guy that's a Brian Regan fan in the room? He's got a joke. It's called, hey, you had logs? Because he says that one of the oddest things on the highway is to see a truck filled with logs going that way on the highway and a truck filled with logs going that way on the highway. And he says a simple phone call would have solved that problem, right? Oh, you had logs? So his joke, not mine, by the way, I'm not stealing his joke. But the point is, very similarly, as we looked across the agency and many things, including aircraft, we said, oh man, we are duplicating this many times over. We don't have the money to do that. There's no reason to do that. So in terms of when we did it for aircraft or for other purposes?
For aircraft.
Yeah. So the question was, what year are we talking about for aircraft? So I have been in this position for all of 1 year. So maybe the year prior to that, they started looking at the problem, and it was our own Steve Jerzik actually that took the stroke of the pen and said, you know what, we're going to do this because we need to. So
When our hangar was downsized.
That's right. There was a 757 and some downsizing. Yeah.
90?
Yeah. So the statement was made that the same sort of thing was done in the 90s timeframe associated with the 757. Yeah. So with the lack of any sort of horizontal enterprise level management, we landed. So that problem, which became a problem again, all of a sudden became my problem about a year ago. So they said, hey, we need to manage aircraft from enterprise model. We need to take a look and see why we have flight operations here or here, how many aircraft we have. Do we need that many? Can we use commercial aircraft services to get some of the things we need so that we don't have to actually own it? It's very similar to the situation that HEO sees itself in today with low Earth orbit. They recognize, hey, commercial entities can do this, and they should, so that we can go do these other things, right? So we're not going to stop giving up on technology development and the things that are actually our bread and butter. However, we do have to start letting go of some things so that we can lean into others. The analogy I use, and forgive me because maybe it's not a great one, but I use the analogy with roulette. If you go to a roulette table, and I've made this comment a million times at center leadership retreats, because I feel like at Langley we do this sometimes. We go to the roulette table with a stack of, how many? There's 36 spots plus 2 green ones. I don't remember, I haven't gambled in a while. But there's 36 spots on the table, and there's 2 green ones. That's kind of the deal breaker. But I know it's 36 spots. And if you walked up to it and you had 36 chips, and you put them all over the table, and then it lands on it, right? It pays 35 to 1, so you land up with 36 chips. And the thing is, you got nowhere, right? You did all this you spread it so thin all over the place, and we're going to win. And then you win, but you really didn't win because you spent so much effort in these areas that weren't winners. So from my perspective, what we need to do as an agency is to start looking at, hey, where are the areas? Let's not put them on all the spaces. Let's pick the spaces carefully and stack those chips higher. so that we have more of an impact on the nation, on the agency, for the people. We have a bigger impact because we picked the spots. We may not win them all, right? We're gonna certainly put more than we think, but putting them on all the spaces doesn't work. And I feel like that's what we've got to do. The same thing with commercial aircraft services, the same thing with HEO, with low Earth orbit. Hey, we got to give up certain things. I'm okay, right? Shuttle program's over. Man, we did low Earth orbit. We dominated. We developed so many technologies. We handed those now to the American industry, which is the best on the planet. And we say, hey, you can do this now, go do it. And now we have entrepreneurs that are willing to do that and invest in those things, to go to have their footprint up there now so that we can go do moon, Mars, beyond, develop the technologies. Similar in aircraft, not quite so cool, I guess. But the aircraft services that we can get from commercial entities that can now do some of the things we could do, we need to do that and be okay with it and say, man, there's nothing wrong with us giving that up. Let them, they're capable, let them do that so that we can take our money, our chips, and stack them someplace else and get a higher return on investment. So there's a point. So I got pulled into headquarters to be the director of the new office. So aircraft was not a capability before. It was a new model. It's a new idea. So I had to stand up an office and create kind of the rules by which we were going to operate and determine where the boundaries of the roles and responsibilities of this office started and ended, compared to where the center director's responsibilities and authorities were, compared to where the mission directorate's authorities and responsibilities were. And it has been an eye-opening evolution for me. It has forced me to look at the agency kind of as a whole, and then narrow down through our little aircraft world and see how we match up with the rest of the agency. And it's been difficult. And I wouldn't say I love it, but I do think it's necessary. And very similar to a pilot that hates machines that fly themselves better than I can fly it, I recognized very quickly that was truth. And I recognized very quickly that we needed this change. So we drove into that change. I embraced the position. I'd like to say that Clayton gave me the opportunity to back out of it, but that wasn't true. He said, they're called orders, Shane, and that's what you're going to do. So I did. And I'm just kidding. I embraced it wholeheartedly. It's a great opportunity to make a massive impact on the agency. So it does bring about the second issue. So we did have a sub-optimized system by a series of 10 centers. In this case, there's only 6 or 7 that fly airplanes. And it depends on how you slice it, because if you say UAS, then there's 7. If you say aircraft that are inhabited, there's only 6. So I do know the number. I know the number. It's just they're going to say that the director of aircraft operations doesn't know how many centers fly airplanes. So as we look at that, we need then to take that model back. But we said, hey, in that world where we've developed these kind of sub-optimized systems, we need to hash some of those things out. So there's problem number 1. Problem set number 2, and I would argue these are both cultural problems to some extent. So cultural problems take time to solve. The next issue we ran into is, and this may shock you, but NASA is reluctant to change ever, for any reason almost. It's remarkable. We resist change, and I think some of that is real and valuable because of what we do. So when people say, why is NASA so bureaucratic and resistant to change? I would argue, well, because our decisions can kill people. So it's important that we make the right decision and that we double down and we validate and make sure. But you can't do that forever. You got to get some balance there. So we're reluctant to change. And I guess the greatest indicator of that from my perspective is, and I think it was Jill, maybe it was the first one that mentioned it to me. We made a decision at CLC. I shouldn't call you out, Jill. Are you on? I'm sorry. I shouldn't call her out. But I was back when we were both at that CLC table. She leaned over and she said, and I was like, man, they just made that decision. She said, the decision is just the start of the conversation. And as a military guy, I was troubled by that, because it was like, hey, when we make a decision, that's what we do at NASA, right? We make a decision and go because the boss said so. But that is not the culture. There's a reason why that's not the culture. And that serves us in some capacities. But our resistance to change is hard when you're trying to drive transformation, which is really what I've been asked to do. I've been asked to transform the way we do aircraft as a business model in the agency. It is hard because then you say, hey, you once had this area of responsibility centers could go and find their own work and determine what they wanted to do. And now there is this rascally capability office that says, we don't need you to do that work, sir or ma'am. We need you to do this work over here. Can you adjust what you're doing? And nobody likes to be told what to do. And this agency's hard at change. So the challenges that I've seen so far, the big challenges are reluctance to change. And like I said, some of that's good, some of it's bad. But it always makes me the bad guy, which is hard. And then the next piece to that is hey, we have developed this problem over decades of sub-optimization as kind of a model. So we have the model to overcome, and then we have a little bit of a cultural issue to overcome. So those have been the big challenges. In 1 year's time, we haven't made, I would argue, we have not made major progress. I feel like it's incredibly slow, but I guess it's just because I kind of hoped for this faster pace. But I realized that in order to get people to come with you, this is a cultural change, and therefore you need to let it has to take time. Any culture change takes time. You can't do it overnight. You can't just make a decree that you all now feel this way, and that won't happen. It does not work. So the changes we've made have been incremental, impactful, but I think largely they're the acceptance of now there's this new way of managing aircraft, and Armstrong is a perfect example there. We've made some decisions here recently that have been hard on Armstrong. We do try to balance it and make sure, because we know Armstrong is necessary for the agency, not only necessary, I argue necessary for the agency and the nation to keep that test facility healthy. But it may not look like they want it to look. We have to kind of help them see the way the agency needs them to approach the problem. Okay, so that's we covered my background here. We covered the job at headquarters and the challenges with that. And I want to pause again to see if there are questions associated with where we sit in the meeting today. Yes, sir.
I had a question following up on what you just said. One of the biggest challenges with getting the people to change is the individual researcher. So I've seen a lot of cases, I'm sure a lot of people have, where the direction at the top changes, and yet you have individual researchers and they all have their pet projects. And somehow, even though the projects change all the time, that technology seems to still be there year after year, project after project. How do you get the individual researchers to change, even though you've already made the change at the top?
Okay, so the short answer is Steve. I'm just kidding. I saw you sitting there and I knew I was going to get you. So it's Steve's fault and it's Steve's job to fix, and it's in his performance plan. If he doesn't get it fixed by next performance cycle, we'll hold him accountable. No, the question has to do with, and I think the microphone is working, so I hope, but I'll duplicate the questions just in case. But the question is, how do we get the individual researcher? Because you're 100% right. We can talk about centralized decision making and things at the highest levels, but if it's not there at the grassroots, then it ain't happening. Let's just be clear. So first, I'm going to defend them for a second. Allow me to defend them for a second over a couple of things. So first of all, this agency, whether we like it or not, and by the way, I'm not going to say anything illegal, immoral, unethical, and I'm not going to talk about religion. I'm not going to talk about politics. Those are the things that are off limits. I won't touch them. That said, I will tell you that we are a political organization. And what I mean by that is the agency shifts its path. So in the DoD, there are small changes, but ultimately the lethality of the organization is your measure and your metric of success. And that becomes clear no matter what the administration is. They can make minor changes, but at the end of the day, it's like, how lethal are you to the enemy? End of story. This agency literally changes its target from administration to administration. I don't say that I love America, and I'm a proud believer in our way of life. So that is the American people speaking through their votes, and it's important. But it's hard because to the individual researcher, from their perspective, it's like, well, you guys said on Tuesday that we were doing this, and then on Wednesday you came in and you said something totally different, and now my world is important to you all of a sudden again. And I'll bring up an example, and it's actually, I would argue, a good example to say why we shouldn't do this, but it's also a good example of why this is it's a self-fulfilling mindset. Hypersonics. 10 years ago, 8 years ago, hypersonics were almost non-existent. We were the only ones who were doing anything with it anymore. Nobody cared. It was passe. And if you talked about hypersonics, they'd yawn and go to the next room and say, let's talk about autonomy or something cool. And nobody cared about hypersonics. Then all of a sudden, right, we had a couple near peer competitors in the world in terms of military capability. And we can't get into the reasons why, but all of a sudden we were like, man, hypersonics are important. We should be doing hypersonics. And the nation looks around and said, hey, who's doing hypersonics? And lo and behold, in Steve's organization, we had a few folks that, despite being told hypersonics were passé and useless, they had continued to work in that area. And now all of a sudden it's the most important capability in the, I wouldn't say that, but it is a very important capability. And those researchers, all of a sudden their research that had continued and their capability that had continued in terms of facilities and capability and capacity to do that sort of test work became very important again. So of course that sort of I'm looking for, it solidifies in their mind, in their heart, that I was doing the right thing this whole time by holding on to that, because now I got this that works. And there are other examples. I won't bring them up because that was a successful one. There have been some less successful ones. But so in their mind's eye, we have administrations that change repeatedly, and they change because of the American people's votes, and that's how it should be. And it changed directions, and that's how it should be. But with that era of change, they're like, well, if I just wait it out, right, man, this will come back to me. And then there's examples where it truly has worked. So in that environment, of course, they're like, well, you can tell me to put it down, but I'll tell you, there's this thing called white space, and I'm going to do it in my white space, and I'm going to keep my research going because this is my baby, and this is the area I've been in. So really the question is, how do we balance that, and how do we get them to buy into this bigger thing? I wish I had the answer, but I will tell you this. We have, as an agency, I would argue, we struggle with, I'm checking my words very hard here, Vicki, you can see my brain working. I would argue leadership in this agency struggles with making a hard decision and then kind of, I hate to use the word enforcing, but really saying, hey, this is, no kidding, this is what I need you to stop. Cease and desist, I'll work in that area because we're not doing it. Yours is one of the chips, unfortunately, that we've pulled to stack somewhere else. So there's two parts to that. There has to be a hard decision to pull the chip and stack it someplace else. Unpopular. By the way, my entire job at headquarters is unpopular. Vicki was making a joke earlier, and it's true. Every time I show up, I'm like, I'm from headquarters. I'm here to help. And they literally want to run away. But we have, so we've got to, the decision has to be made to hey, we're going to stop doing this. Then down to the supervisory level, it has to be, hey, no kidding, I don't want to see you working on this anymore. We're giving up the hardware. We're putting it away, or maybe putting it in mothballs in case it comes back, but we're not working on it anymore. So there's the next step. And then the last step has to do with, hey, you don't want to just leave the person hanging there, because then they feel like, well, now I guess I'm not useless to the agency. You need to take their chip and stack it someplace else and say, hey, but I can use your skills over here or over here and repurpose, reuse their skills so that we can make them, the agency is people, right? We have hardware, I have aircraft, man, but the people in this room that do the things we do is really what NASA is. And it's the expertise that makes us great. So if we allow those people to feel like they're not a part of something or don't use their talents, then we are the ones to blame within ourselves. So there's kind of that 3-step process. Have we done it? The answer is no. Do we do it well? Not yet, but we're starting to talk about it, and that's a good step in the right direction. Steve says he's got it solved. He's going to do it next time. Excellent question. I don't have a great answer for you, but I know that there are those steps that have to be accomplished to get there. Thank you, sir. Yep.
Okay, one question from online. Olaf, why don't you go ahead and ask your question?
Yeah, I remember in the past we had changes from aeronautics to space and so on, and it was hard for the management to get everybody on board. So they encouraged, they liked the book, Who Moved the Cheese. They got a bunch of copies and encouraged high-level people and researchers to read it and kind of be open-minded about it. I read it and I thought it had some good ideas. Have you read it and do you like the ideas?
So I have read it, that and about maybe 12 other leadership management books, and I do like the ideas in there. And I guess, and without getting into individual techniques or ideas incorporated in the book or others, another good book, by the way, that's an excellent one. One of the other books, Good to Great, was another book. It's kind of antiquated because it was talking about specific companies. And then there have been a few others. But I think if I were to point us in a direction right now, because I don't think, I think the solution set is around and circles around, and the nucleus of solutions revolves around supervisory positions and leadership, kind of not at the executive level, but down where folks are, no kidding, working on a day-to-day basis. So if I would point you to a book, and I can't, this is not, I'm not telling you to go out buy a book. I'm not selling anything, and I get no proceeds. But I read a book by a Navy SEAL, it goes by the name Jocko Willink, and he wrote a book with a guy, another guy called Leif Babin, I think his name was, and he wrote a book called Extreme Ownership. And you might say, well, what do Navy SEALs have to do with NASA, and what is extreme ownership, and what does that mean? This is what I would tell you. What it is if you do not pass the buck, extreme ownership is, hey, whether or not you had control over it, you were party to, and even if you opposed it but allowed it to occur, you were party to whatever happened. So ownership of that, regardless of your position, your thoughts, ownership of anything in leadership is important. So extreme ownership is, even if you don't control or adjust, or even if you have nothing to do with it, it's so powerful for someone to say up and say, mea culpa, I own it, right? I got it, my fault. So to get to the point that was made earlier, and I appreciate the question, I think the key is to get to, hey, if we continue to pursue areas that we shouldn't be pursuing, who's to blame, or who's at fault for that? Well, you can't, to my point earlier, you can't blame the individual researcher. They have nothing but evidence to show them that they're doing the right thing, and they have a lifetime invested. Where it's that first level of leadership, that first level of supervisoryship, that I think you have to get them to invest in something else. You got to get them to believe in it. You got to explain to them the why we're doing this. We can't keep doing this. We're going to go over here, and this is why. But it is that all the leadership skills in that first level of leadership, I think, that have to drive us to answers, and them to take complete responsibility that we will get into these areas and out of those, because otherwise they're just talking points that some guy in a tie gets up and talks about, unless someone actually owns it and says extreme ownership, I got it, right? And if we fail, I failed. So once we get there, I think is the best way to do it. I think there's tools and techniques in a lot of those books. The cheese has moved. I 100% agree with you. I 100% agree with the idea of the book. But really, how do you implement the change? And I think the key there is ownership at a very, at the first level of leadership that drives the change that we get places. Does that answer your question, sir?
Yeah, thank you very much. And I think I might look into that ownership book. Can I follow up with a very simple question? A very simple question I think you'd love to answer, and I'd like to hear your answer. I saw Top Gun 1 way back, and I thought that was a wonderful movie. And then I went and saw the new one, and I thought that was even better. And when they went in and then took off, and after the mission, and went up high, was that realistic to you?
Which part? So I did see it. Which part, when they went up?
Well, they went maneuvered through the mountains back and forth and did their mission, and then they had to escape, and they went straight up in the air. It seemed incredible.
Yeah.
Did that make sense?
So the question is whether or not I like Top Gun. So as to the realism, so I do. Believe it or not, I get this. I'm in an adult hockey league here. I play at a. I played hockey all my life, and then hung up my skates for 20 years. And then actually, my daughter of all people wanted to play ice hockey. And I was like, she does ballet and ice hockey. What a combination. It seems weird. But I was like, sweetie, you can do whatever you want. And I'm here to support you. And she said, well, here's the problem, Dad. If I'm going to play hockey, you have to play hockey. So I got a new pair of skates and started playing hockey again. Anyway, I said that to say, in the locker room when the new Top Gun movie came out, the key question was, well, like, how realistic is that? How realistic? And I would tell you, it's a movie. And as disappointing as that is, like all things, there is a lot more to flying any mission in any aircraft that is laborious and monotonous and boring, and mission planning and studying. And hey, in that movie, there was a time when Tom Cruise, who of course he's Maverick, so he gets to do whatever, but he went out with a Hornet, and in order to demonstrate, he over-G'd the aircraft, which is a Class A mishap. The airplane has to be struck. The wings are no good anymore. The plane's no good anymore. And if anybody did that in the real Navy, That would be their last flight ever, ever, ever. Doesn't matter what his name is. So there's a lot of kind of falsehoods in the movie, but I did think that it was interesting. They set up the circumstance such that there was enough realism in the mission and enough realism in the planning that you could at least suspend disbelief for a little while and enjoy the action of the movie. Yeah, and yeah. So I'll leave it at that. The individual maneuvers and things are some of those things are. Well, I'm going to use the term classified, which is to say they're confidential or higher, but how we defeat weapon systems and things are, and the techniques that we use to do those things are very specific. So we don't trade those, even with our allies, by the way. A lot of times we will train with them and then we won't use the very maneuvers that we would really use because we're like, we know how that works and you don't, and that's the way we want it to stay, right? So that's how that goes. But a Hornet driver could tell you better as to whether or not they would really want to do that. I would not get into the tactics and techniques, but it was an excellent movie. My kids love it. By the way, my son and my daughter, they literally broke out. They broke out old flight suits of mine and they put on flight suits and went to the movie in flight suits. I was like, you go. It's all right. Yeah. Great. I appreciate the question though, sir. Thank you.
Thank you very
Okay,
much. I enjoy it. And I play hockey too. I grew up in Canada.
Excellent. Yeah, I grew up in Maine, so born in Massachusetts and raised in Maine. So hockey it wasn't a question. It was just how much you were going to play. Right? Yeah.
All right, and with that, we're going to close out and thank Shane for that. Oh, that was a wonderful talk. Thank you.
Very good. Thank you. Thank you. I appreciate you guys.